Good afternoon, guys. My name's Alan Page and I work for Pfits Consultancy. Our head office is in Christchurch, and we have a small office in Auckland. There's a couple of us in Auckland. So there's two of us that heads up either side. I head up the passive fire side and my business partner is the true fire engineer. One of the things over here is you hear a lot about passive fire engineers over here, but it is a New Zealand term. If we're in the UK now, I would be called a technical engineer or technical director, which is why my title is technical director in New Zealand.
Can everyone hear okay? It's okay. Might have to speak up a bit.
So what is passive fire protection? Well, passive fire protection is all the integral components, so that's your walls, your floors, everything. And it supports the structural stability of the building and the fire safety of the building. And also it's there to contain and slow the spread of fire. So passive fire is a collection of all non-active elements. So things like sprinklers are active, detectors are active. It's anything that does nothing. It doesn't react. It generally just either closes or it just sits there in a passive capacity. And sometimes for a QS, when they suddenly get the bill from a passive fire installer at the end of the job, it's a sharp intake of breath, and it certainly is for a client, which technically they don't see what they've spent the money on. It's all hidden. So what is it? It's the first and last defence in fire protection. It's the first line of defence because obviously when a fire first starts, you get a lot of smoke generated. And as a fire propagates and gets larger, that smoke then turns to hot smoke. So if you've got any holes, imperfections or whatever, the smoke will find it. So all of a sudden you'll find that your corridors are filling up with smoke. Staircases could be filling up with smoke. Rooms could be filling up with smoke. Now we're very lucky in New Zealand because we have a very strong sprinkler industry. So in the middle, we then have a sprinkler. So once the sprinkler bulb activates and the fire starts coming under control, then generally that's the end of it. But what happens if you have a fast-moving fire? Something like Grenfell, where it tore up the outside of a building or tore through rooms. That's where sprinkler systems become overwhelmed. Even if you've maintained your sprinkler system and you've looked after it over the years, they can still eventually fail. And that's when it becomes the last defence. And that was one of the problems with the Grenfell fire in London. The Grenfell fire in London, the building had no sprinklers. So the only thing that the UK was reliant on was a passive fire. And the UK is very still heavily passive fire. They've moved a lot in the last few years over towards more active. And in fact, I've just had 10 months back there and I've just come back at the weekend. So, but they still have a huge passive fire reliance, not so much sprinklers. We also have we sort of have a balance here. So what is the role of the engineer? So the role of the engineer really is, as Jeff said, that you get a fire report, and normally my business partner would do the fire report or another engineer would do a fire report and we would receive them. We would then take the fire report, we'd then look at it across the drawings and we would look at all the penetrations. We'd try and find out as much as we could of what materials were going to be used. So we'd also take anything from HVAC, we'd take electrical, we'd take hydraulic, we'd take whatever services were going through the building, ductwork, whatever. And we would look at that and we would look at where it passes through the firewalls or through the floors or anywhere else where there was a fire risk. And then what we'd then start to do is we'd then start to design it. Now the way we design, and I was trying to think the other day as how far into my career, and as somebody said it's 35 years, and I can remember saying to someone that had been in the industry 35 years that they were a dinosaur, so that makes me a dinosaur now. But I was trying to think how far into my career it was before I actually started to design, and it was 17 years. I was 17 years into a career which went across all sorts of things. So I started off as with a materials manufacturer. I then moved into fire stopping. I then moved to a main contractor. I then moved to a subcontractor. I then worked for a test house. And then eventually I went to work for a consultancy. And it was only at that point that I was allowed to design anything. And even at that point then, I was still overseen. I wasn't given free rein. So what I'm trying to get to is that we see, at the moment, we see designers coming through in New Zealand in particular that have very little design experience. That's one of the big problems we've got. And we see that when we get out to site, because sometimes we're just employed to do third-party monitoring. And then that's when we generally find that there's issues. So we see poor design and specification. Now, Auckland's gone a long way towards rectifying that with what they do, but other councils are not so. They will still just take whatever's sent into them and they will just pass it off. So we have limited trained applicators. Now, what we mean by that is in New Zealand, we have competence level 4 training for applicators. The competence level 4 is a good step in the right direction, because when I first came to New Zealand there was nothing, and that wasn't very long ago. That was 2016 I arrived, and there was nothing for applicators then, absolutely nada. So at least we've got something. But the problem with competence level 4 is there is no on-site observation. It's all done electronically and it's all done online. And once you've got that, then you can actually go out and you can install passive fire protection. So people learn on the job, basically. We've got the same problem with the inspectors, because the inspectors are doing the same course. They're doing competence level 4, or they do the IQP training course or whatever. So again, limited trained inspectors. How many here think a fire engineer is trained to look at passive fire? How much time do you think a fire engineer spends on passive fire in their 2 or 3 years in university? I don't spend 1 minute of one day. And yet we're expecting them to go out on site. When I first came to New Zealand, I started with a fire engineering company, and my very first task was to train the fire engineers to start being able to go out to inspect. Now again, we've come a long way, because the fire engineers now are also doing some of these courses as well. So we then get PS3s, which are coming through from the limited trained and or experienced applicators, and they then get sent to us for us to PS4. Now again, Jeff alluded to the QA. Now the QA again now it's leaps, it's infinitely ahead of where it was. We get really good QA and we get really bad QA. Now you can imagine, as an engineer, once I sign the PS4, I take ultimate risk for that job. The applicator doesn't take ultimate risk. So if there's a problem in the future and I've missed something, then that's me. I could be sat in my rocking chair in a few years' time and suddenly get a tap on the shoulder that a building in Auckland's burnt down because I didn't do my job properly. So we're quite hot on what we do. So when we join all that up, the problem is it can still give a non-compliant building, and Jeff alluded to the fact earlier in his presentation that they're still, the council are still seeing mistakes being made on site. So where is passive fire specified? It's specified in all of that, generally. So it starts off with the Act, as Jeff said. It goes through the code, the standards, tender docs, contracts, design documentation, product specifications, consent docs, producer statements, and the CCC. But what we find a lot of the time, it's not in the building. Again, we still attend jobs even now, and we would put it slightly higher than 28%. We see probably, at least 30 or 40% of work at the moment across New Zealand. This is not just Auckland centric. Across New Zealand as failing. We'll pick up a problem. We also see, because part of the passive fire isn't just penetrations. Part of passive fire is the wall that the penetration goes into. Now, one of the things we don't see at the moment is we don't see anything from any main contractor given to a subcontractor that says that that wall has been signed off. So if you haven't got that piece of paper from a main contractor to say that wall's signed off, and the passive fire contractor then installs all of his passive fire in that, and we come along and say that wall's non-compliant, the passive fire contractors actually own that wall because he said it's okay because he's put his passive fire materials in it. So these are all the issues that we encounter. So we see sometimes there's no design. We find that there's a big move now to BIM. How many of you have used BIM? How many of you are out on site having used BIM? And how many times do you see BIM and what you're getting installed not exactly right? A lot of the time, yeah. So we then get incorrect installations to designers, installers, lack of knowledge and experience. We've now got a problem in New Zealand where we've now got a limited product supply. We see it all the time. People can't get materials, and as Jeff alluded to earlier on, there's now a method for you changing products out. That's had to happen because sometimes you just can't get what you need, or you can't get it in time. Supply chains have really been stretched. There's high product costs as well. We see product costs, or I see product costs, particularly in New Zealand, just astronomical compared to what I see in the UK. A tube of sealant over here is about 5 or 6 times the price of what I would pay for it in the UK. It's as simple as that. And it's come out of the UK. We get disputed products. BCAs will dispute products. They may not have the right test, or they may not have the right information. We also see the inspectors sometimes identify something that's then been missed earlier by the consenting teams. And we also have a lack of training, and the lack of training is more practical training than it is theoretical training. So why do we need the training? To stop that sort of thing. Now that we saw around about a month ago. That was a job that I was on 10 months ago. And I had a PS3 for that. That was 6 months ago. So it's still happening. We're not saying that you've not moved on, and I'm not saying that you've not moved on. You have. What I'm saying is, when you come to inspect something, that looks great, doesn't it? Would you not agree? It looks a really nice, tidy install. Don't look so tidy now, does it? That's the lengths we go to. We take it apart. And you can see by looking at that, there's all those crosses. But if you look in the top right-hand corner, you'll see one tick. Because they got one screw right. The rest of it was wrong. And that was a hospital, which made it worse, because you've got immobile patients. So how do you set up for success? Engage a designer, somebody that really understands passive fire. And also engage them as early as possible, even probably early on in the planning stage. Get somebody who's qualified. So the first thing you should be doing is ask for people's qualifications. You know, even if it's competence level 4, that's fine because it's a qualification. So you need to ask for people's qualifications. Also ask for previous project experience. I mean, I've probably done more projects and forgotten more projects now than I've done over the years. So, and communicate. Make sure your designer is aware of any changes because it affects things. I mean, one of the things I was talking about earlier on was plastics. Plastics is the biggest pain in the arse that there is going because there's so many different ones. You know, all of a sudden you can have copper at one point and then all of a sudden you find it's been swapped to a plastic. Now that's a totally different solution than what we've put in. So this is what's called the McLeany, even I can't say it, the McLeamy curve. So what it does is the ability to affect costs and functional capabilities is always early on in the project. It's never towards the end of a project. And the cost of design changes, as you go through the project, the cost of a design change starts to go up. So you'll start off with your budget, or you may have a PC sum or whatever it is that's in there at design stage, but you get on site, things change, and all of a sudden the impact of the design change has suddenly impacted the costs. The traditional design process is like this. So we do a little bit of pre-design, there's a bit in schematic design, and then you go through the various construction elements, and then once you get in construction it generally drops away. Does anybody care to know where passive fire actually still sits at the moment in New Zealand? Generally. I'll show you in a second. Because once you've got the integrated delivery project process, it actually moves it forward slightly. But passive fire generally goes there. You'll hear so many people, if you talk to project managers or installers even, you'll find that a lot of them will say somebody's suddenly told them they've forgotten about it. How can you forget about it? So performance is all down to time, cost and quality. Once you've got all of those together and you've got the whole project set out, then generally you shouldn't really go wrong. I was saying earlier on, the amount of RFIs that I see, and Jeff said that early on he doesn't like sending out RFIs, but the amount of RFIs we get once we're on site is enormous, and we shouldn't really be getting them because we've designed it out. But we do because there's a change. Or all of a sudden somebody's forgotten something. I mean, I'll give you for instance, this morning, I had an A-Connect come through this morning around some structural steel work, and the guy saying to me that he can't do the structural steel work the way he wants to do it. And he sent the design over, and he's correct. When I looked at the design, he couldn't do it the way he was doing it. So I rang him up and I said to him, so where are you at the moment? He said, well, we're at the 9th floor. I said, but this is the 11th. He said, yeah, that's correct. I said, is the roof on? He said, no. I said, so you can do it then? He said, oh yeah. I said, so why have you suddenly sent me a thing saying you've got a problem? Oh, I'll just send you it just in case we have a problem. Now, I would have spent time designing him out the problem for a problem that don't exist. That job's in Auckland. So time, it should be well contracted. So you should have standard contract conditions, program, project managers, project quantity surveyors and construction managers. If it's contracted, the quality could be at risk. So if you've got incomplete design, or the scope is unidentified, or you have multiple subcontracts, or you have lack of attendance on site, then the quality can slip. So in other words, one of the things I would say to you is if you've got a passive fire subcontractor and they send Bill and John to the job, and Bill and John start the job, but part way through they're pulled off and another set come to the job, that can impact your quality because you've got a different team. And the other team has then got to try and pick it up from there on in. And that's where we also see a problem, where we'll go to one job and one bit of it will be fine. Then we'll go to another bit and it's different. And then we'll look and we'll see that all of a sudden the teams have changed. So some of the really difficult projects we've done, one was Grey Base Hospital in Greymouth. Now, as an example of what happened was Fletcher's called us into that job very early on. They hadn't got a proper design for the job. It was in the crap. They'd they'd had problems with intumescent and they didn't want the same problem with passive fire. So what we did was, over a 2.5 year period, was we actually worked with the contractors on the job and we trained them on the job. When we got to the end of the job, the snag list was 29. Compare that to the DHB hospital in Christchurch, where they got to the end of the job and there was 45,000 snags in passive. The Maui platform. I went out to the Maui platform. I had to do a condition assessment on the Maui platform. I don't know how many of you know the history of oil and gas, but have you ever heard of the Piper Alpha disaster? That was the largest loss of life ever, and it was in the North Sea. It was 130 odd people because the platform blew up basically, and they got no refuge. The Maui platform was its sister platform. So when I went there, there was no refuge. So if the alarms went down, everybody went to the lifeboats, and that happened 3 or 4 times while I was actually on the platform. So eventually what we did was we designed and built a safe refuge for an hour. So now if there's a problem, they've got somewhere that they can go, or somebody goes and checks and see if there really is a problem. Wellington Children's Hospital, we were called in by the main contractor on Wellington Children's Hospital because they'd had a design come in from the fire engineer. They went to order the products and they weren't available in New Zealand. So the thing had to be redesigned. And that had gone through consent. Ōtautahi Apartments in Auckland, we were brought in by Fletcher's because, again, this was an old job, so it was retrospective. It had been signed off, it had been passed over. Somebody started complaining that there were smells coming in from the people next door and down below and what have you. When they started stripping back to see what had gone on, passive fire had been missed and not done. Had they have had a fire, they'd have had a catastrophic loss. And again, we were on that job for about 2 years sorting that out. And that was ongoing because as they unearth something, they'd unearth a different problem. So there was lots and lots of design went into that. And that's me. Any questions?